So the last one that we're on is IOC extraction and rule generation. So when we have a look at cyber threat intelligence, quite often it's not coming in a nice format that's easily ingestible or automatable. So what we call actionable threat intelligence. Quite often these are reports delivered through PDFs or websites, right, or over email, depending upon what has happened. So what we want to be able to do is get those documents and utilize the power of LLM to be able to process the natural language to extract the indicators of compromise out, put them in a structured format, and then actually generate rules for, say, a SIEM or an IPS or a Yarrow rule to be able to search for files, for example. Right, so there was a recent Fortinet vulnerability that came out. There wasn't any exploits. It was a critical remote code execution vulnerability. And so we went and wrote some post-breach IOCs within this blog post that we sent out to our clients to provide them with potential indicators of compromise based off Fortinet security breaches that we've seen in the past. So you can see some of the custom post-breach indicators that we can see within log files for Fortinets, but also it was around the same time where there was some Vault Typhoon IOCs that were released. So you can see some of the file names, the hashes, the IP addresses and domain naming here. So again, this is traditionally not an automated or actionable intelligence because it's not easily consumable and automatable. Whereas now using LLMs, we can actually do that. So if we have a look at we've got from threatintelligence.com, we've taken that web page, converted that into a PDF, and then we've got this prompt to actually go and analyze that page and extract out the indicators of compromise around the IP addresses, the domain names, create a snort rules to alert on malicious activity, as well as create a Yarrow rule to be able to search systems for malicious files and file hashes. So if we just go back and we will upload the PDF file here, and this is our last section. Okay, we'll submit that. And straight away you can see that from that unstructured text, we've been able to get these snort rules created with the malicious IP addresses and ports that they're connecting on. And you can see there's even a description, potential malicious activity detected relating to Vault Typhoon with that IP address. You can also see a DNS snort rule, suspicious DNS request to that domain name, which was in the page as well, listed under the indicators of compromise. So they're the network-based detections that go into snort. And then we've got file-based detections, which we want to create Yarrow rules. So you can see here it's created a Yarrow rule, Fortinet post-breach IOCs for Vault Typhoon. Rule detected, the files associated with it. It gives some references to where it came from. And then you can see the string. So you can see the service executable name, and you can see a few different types of file hashes for that executable, as well as the other executable that was mentioned and the corresponding file hashes. And then it says the condition for the Yarrow rule is any of these indicators should match, so that when you search across your environment for the Yarrow rule, for these indicators, it will match on any of these and actually flag an alert. So that's how you can automatically generate these using your LLM by taking unstructured text and actually turning them into actionable intelligence. So again, these, depending upon how mature your automation is and your analysis around this and your prompts will evolve over time and become more and more accurate. So in the short term, you do want to actually review these before you push them through to production systems, just because you will find that, you know, because of the various files that you might be parsing and the indicators that they may extract, you may find that you've got some false positives in there. So if we just take another file, which was actually a security alert from the ACSC, so a ransomware advisory, we give it the same prompt. So again, it's a generic prompt, just a different file, completely unstructured text. And you can see again, it's created the IP addresses, the domains to be filtered on. And then you've got the error file and the indicators that are provided within that ransomware advisory. So if you actually have a look at that ransomware advisory, it lists all of these as the different tools that the threat actor uses, and then it gives some arbitrary hashes around some of the executables that they're known to have had. So that gives a really good insight into how you can take unstructured data and actually turn it into actionable intelligence. We want to automate the analysis of free text documents to be able to extract out indicators of compromise. We can do that again from the command line. So in this case, this script supports downloading a file or multiple files from the internet, uploading those for analysis, and then providing this prompt file to be able to instruct it on what we want it to do, how to analyze the file or files, and also how to handle the output, including, you know, how to analyze domains, how to analyze IP addresses, as well as file names or file hashes. So again, depending upon how many files you submit and how large those files are, you know, will determine how accurate this is, or sorry, how fast this is. The accuracy, you need to keep working on your prompt file. So I recommend that, you know, as you keep testing this out with different sources of intelligence, that you keep tuning your prompt file to be able to handle different scenarios, and also have a look at the source file to see what you've missed or what ChatGPT's missed, so that you can improve the prompt to be able to extract out more and more indicators of compromise, so you can get the maximum intelligence out of the free text intelligence documents. Okay, so you can see in here that it's created a Yarrow rule, which has a series of hashes in them, as well as potential snort signatures for potential domains that were detected within the file as well.